Okay, class. Now we are studying next point, introduction of Python, unit number 4, lecture 4, that is regression matrix. First of all, we understand what is the regression matrix in machine learning. Machine learning is an effective tool for predicting numerical value, and regression is one of its key application. The regression matrix is the key application for the matrix. In the arena of regression analysis, accurate estimation is crucial for measuring the overall performance of predictive models. If we talk about the estimation, accuracy, regression analysis, and overall performance of the model, then we have to talk about the regression matrix. There is where the famous machine learning library Python Scikit-Learn comes in picture. It means the regression matrix is done by the Scikit-Learn library provided by the Python. Python provides so many libraries like pandas, numpy, etc. But the Scikit-Learn is also provided by the Python as a library to work with regression matrix. Scikit-learn gives a complete set of regression metrics to evaluate the quality of regression model. The Scikit-learn provide us a complete set of regression metrics. Different type of regression metrics is there, and we can evaluate the quality of regression model using or with the help of, you can say, the Scikit-learn. In this lecture, we are able to explore the basics of regression metrics in scikit-learn, discuss the steps needed to use them effectively, provide some examples, and show the desired output for each metric. It means in this lecture, we are going to learn and explore the basics of regression metrics. Scikit-learn library has the different type of metrics, and regression matrix is one of them. Also discuss steps needed to use effectively, means how we can use the scikit-learn library effectively. Some also provide some examples to use the scikit-learn library, and so the desired output for each matrix, means how the matrix and regression matrix generate the output. First of all, we need to know about the regression. If we use regression matrix, then first of all, we should know about the regression. Regression is a fashion or algorithm used to expect continuous numerical values, primarily based on entering features. In scikit-learn, we will use numerous regression algorithms such as linear regression, decision tree, random forest, support vector machines, amongst others. There are so many regression techniques and regression model is available, but here we consider or we explore about such type of linear regression, decision trees and random forest and support vector machines as well, amongst others so many others metrics are also provided. Before learning about precise metrics, let's familiarize ourselves with a few essential concepts related to linear or regression metrics. First, when we talk about the linear regression or any type of regression, then we need to know some basic terminologies which are work or which are used in regression metrics, that is known as true value and predicted value. There are two terms. The one is true values and the predicted values. In regression, we have got two units of values to compare. One is the actual target values, authentic values, and the second value that is known as expected or by our version, that is known as anticipated values, and it is also known as predicted values. It means what we predict for the result. The performance of the model is assessed by means of measuring the similarities among these sets. It means how much the s- values are similar after comparing, after measuring the true value and predicted value. If the true value and predicted values are closely, very close, found very close, then we can say our model is work properly, or our predicted value is very accurate. The second one is evaluation matrix. First, evaluation matrix means if you want to measure, if you want to assess, if you want to analyze or evaluate any model, any matrix, the regression metrics are quantitative measures used to evaluate the needs of a re- regression model. Means if you want to, if you want to evaluate the regression model or regression matrix, then we have to use evaluation matrix. Any type of evaluation matrix you can use. The types of, the next one is types of regression matrix. It means how many regression matrix is there and provided by the scikit-learn library. Some common regression metrics in scikit-learn library. The number one, mean absolute error. It is also abbreviated as MAE. The second one is mean squared error, abbreviated as MSE, and R squared score. The next one is the fourth one, root mean squared error, RMSE. These four type of metrics commonly and popularly used in regression metrics provided by the scikit-learn library. The first one. Now we will explore and we will learn each of the model one by one. The first one is mean absolute error, MAE. In the field of statistics and machine learning, the mean absolute error is a frequently employed metric. It means it is mostly used, mean absolute error. Its measurement of the typical absolute discrepancy between a dataset actual values and the projected value. It means if we talk about the absolute error, mean absolute error, it means it is the discrepancy available or discrepancy occur in between the actual dataset and the predicted or projected values. Suppose any dataset have the actual value like 1 to 3, and if we predict predicted value for 3 to 1, the difference between them, the discrepancy between them is known as, is measured as the mean absolute error. Mean absolute error is a commonly used metric to evaluate the accuracy of a model, particularly in regression tasks. If it, particular the MAE is commonly used metrics to evaluate the accuracy. Or if we talk about the regression metrics or regression type of data, regression task, then particularly it is very useful and very commonly and very accurate model for the assessment. In other words, it calculates the average of the absolute difference between predicted and actual value. Means in general, in other words, or in general, we can say the average of the actual value or absolute value or and the predicted value. The difference between them is absolutely known as mean absolute error. The formula to calculate the absolute mean absolute error, we use the following formula: 1 by n summation of the value of absolutely yi and yi dash. Here n is the number of data points. It means how many data points are involved or taking as a sample data. Yi is the actual value. First, suppose if you talk about the first value and the actual value is 3 and the predicted value is 4, then the 3 minus 4, that is 1. 1 is the difference. 1 is the difference, and 1 is the difference between actual value and predicted value. Now this one is the absolute mean error. Characteristics. uh, Obviously the MAE has some important characteristics. The first one is interpretability. You can say MAE is a straightforward to interpret. It is very simple and very easy to interpret. It represents the average absolute error in the same unit as the data. It means the result as well as the input data are in the same unit, same form, not a different form. That's why it is very easy and very easy to interpret. The second one is robustness. MAE is more robust to outliers compared to other metrics like mean squared error, and because it does not square the errors. The robustness of the metrics is very high, and it is the outliers are very frequently used and entertained in the MAE, and it is very useful or very uh, common or popular as compared to others because it does not square the errors. It work with the actual errors, not the other further calculation is required to perform or to take the result. The next one is range. MAE ranges from 0 to infinity. It means the difference between the actual value and the predicted value may be differ. It may be from 0. If the actual value and predicted value is same, then the difference is 0. If there is difference, then it may be vary from point to point. So where 0 indicates a perfect model, it means no error because of the actual value and predicted values are the same. But if the difference is there, any difference is there, that it indicates the difference or it indicates the accuracy of the model. MA is useful when the usefulness where we can use and the use cases where we can use MAE model to work or to predict the values in regression model. MA is useful when you want a clear sense of the average error magnitude. It means if you want clear cut sense of the average error magnitude, and it's less sensitive to large errors compared to metrics like MSE. It means if the error occurring chances is less, then you can use the MAE method or MAE metrics to execute or to complete your model. You can see an example. So first of all, you need to import the mean absolute method, and it is provided by Scalar Scale-Learn metrics. From Scale-Learn metrics, import mean absolute error. The second one is true values. It means you have to provide the true values. What will be the true values for sets? First value is 2.5, 3.7, 1.8, 4.0 and 5.2. These are the actual values. Here we perform the comparison with the five sets of input sets or five samples input predicted values. If we predict the value for first one is the 2.1, 3.9, 1.7, 3.8 and 5.0. Suppose for example we predict these values. If the actual value is this and the predicted value is this, now we need to calculate absolute error, error, MAE equal to mean absolute error. First we pass the true values and predicted values. Then internally MAE automatically calculate the mean absolute error. And next line print the result, and you can see the mean absolute error is 0.22.00003. That is very minimum, and it is maybe negligible or maybe avoidable in case of the accuracy. It means you can say your model is 0.22% accurate. Error occurs only 0.22, and remaining the values or remaining part of the model is working fine. The second one, now the second model is mean squared errors. Mean squared error is another widely used metrics for evaluating the performance of regression. The first model is mean absolute error. The second model, mean squared error. It is mainly used when the error size is very low or very minimum, very small, we can say. Mean squared error is another widely used metrics for evaluating the performance of regression models. Unlike mean absolute value error, MSE stands for mean squared error, takes the square of the difference between predicted and actual value. First, it calculates the difference between predicted and actual values, and then take the square of the result, which emphasize larger errors more heavily. It means if this error size or error value is very small, then why we take the squares of the difference? Because of we want to make it larger, so we can represent, we can determine the errors more specifically or more heavily. MSE is a frequently utilized in regression issues and is used to assess how well predictive model works. Means when we use frequently utilization of the regression issues, and it is used to assess how well the predictive models work. Means your predictive model, your supposed model or your proposed model, how effectively work. If it works properly or it works finely, then the result is very heavy. Now the formula is very simple. Only minor difference in MAE. MAE means mean absolute error, and here the mean squared error. The formula is same, 1 by n in the summation of I to 1, I1 to n, and yi minus yi dash. It means n is the number of data points and yi is the actual value. Yi dash is the predicted value. So you can say, and you can see the difference between the predicted value and the actual value, and then first calculate the difference and then calculate the square of it, and then summation of all the values, and then put the actual result. Characteristics, it also has the some characteristics. Interpretability, MSE is not as directly interpretable as ME because it is in squared unit of the output variable, but it gives more weight to larger errors. It means it work on larger value errors, more work. Sensitivity to outliers, it means it is finely work with, we can say correctly work with outliers due to the squares ring of errors. If we perform the squaring of errors, a few large errors can disproportionately affect the MSE. Otherwise, all the errors and all the outliers, it works with very sensitively. Optimization. MSE is commonly used as a loss function in machine learning algorithm, particularly in linear regression because it is differentiable and easy to work with mathematically. If we understand and anyone understand the mathematics, then it can be worked finely and with work with differently seeable the result because of it is work on squared of the mean values. Uses. The use of MSE is useful when larger errors are particularly undesirable, as it penalizes them more heavily compared to ME. It means if the errors are very high or very larger, then we can use and particularly desirable. However, because of its sensitivity to outliers, it may not always be the best choice for the data with extreme value. If the values are very extreme, then it may be possible, not always, but it may be possible it not work finely with that type of data. Examples. Now we can take an example for mean squared error from sklearn. Sklearn means scikit-learn metrics. Import mean squared error. That one is a method or function. Here we also provide the some same type of value as true value and as a predicted value. True value is 2.5, also with the same set of data, same input set 2.5, 3.7, 1.8, 4.0 and 5.2. These are the actual or true values. And the predicted values for first set, that is 2.1, 3.9, 1.7, 3.8, 5.0. MSE, mean squared error, we have to pass the true value as well as predicted value as a parameter to the mean squared error method. Now it calculates the difference and then take a square and then perform the summarize form and then print the MSE. It means the result. And you can see the mean squared error is 0.05. In the same example, if we use the mean absolute error, the result is 0.22. Now the result is reduced and the result is 0.05. It means the mean squared value is very useful or very commonly used. The next one, R squared score. R squared score, that one also a linear regression model or the evolution model for the linear regression, but statistically metrics frequently used to assess the goodness of fit of a regression model. If any model is fit or not, you can say fit and unfit for the mm, your model. We use to the R squared score. also referred to as coefficient of determination. R stands for coefficient determination. It quantifies the percentage of the dependent variables variation that the model's independent variable contribute to. It means the dependent and the independent variable, how and how much the variation in between them. R square is useful statistics for evaluating the overall effectiveness and explanatory power of a regression model. If you uh, want to work with effectiveness and explanatory power of a regression model, then we can use R2 is a useful model is.
Now, the next topic is operators in Python. Python supported different type of operators. Operator means symbol which perform something. Suppose if you try to define an operator, you can say an operator is a symbol, sign which performs something is known as operator. For example, if you are performing A plus B, this is known as addition operation. This is whole process is known as operation, and every operation consists two things. One is operator and another is operand. Operand means on the value of which we perform the operation. Like addition operation perform on what? On which? Then we can say we perform addition operation on the value of A and B. So in this case, A and B is the operand, and the addition operation performed by which? Who performed the operation? Then we can say the plus sign symbol is perform the addition operation. So the plus is known as operator. So if we conclude this, any operation have two things. One is operand and another is operator. Operand means on which, on the value of which we perform the operation, and operator means the symbol which performs something. How many types of operation and how many types of operators supported by the Python? There are so many types of operators performed and supported by the Python. Here we discuss some of them. Number one, arithmetic operation. Arithmetic operator means the operators. Suppose you can see arithmetic operator. Arithmetic operator which used to perform any arithmetic. Arithmetic like addition, subtraction, multiplication, division, and modulus, exponential, and floor division. All of them operators, most of them are supported by other languages as well. But one new operator, arithmetic operator, which is only supported by the Python is floor division. What is this? We will discuss later on. Suppose if you want to perform any operation, suppose if you want to perform like a equal to 10, b equal to 20, b equal to 20. And if you want to print a plus b, now run the program. You can see the output 30. It means addition. Here, if you put minus sign, then perform the subtraction, minus 10. If we perform multiplication, asterisk sign, 200. Same time division. But suppose for example, if you want to perform these two operators, all the basic operators, but I discussed last three operators. Modulus. Modulus means whenever, suppose for example, a is 20 and b is 5. In that case, for example, update the value of a is 22, and when we perform a division b, what will be the output? For example, what will be the output a division b? See the output. The output is 40.5 or 4.5. If you take the value of a is 22, 4.4. Now, suppose in some cases we just want the value before decimal point and ignore the value after decimal point. Then we can use the flow division. Now you can see only the value before decimal. After decimal, the value when we perform the division of two numbers. Suppose for example A divided by B, then how many answers is generated? Two answers is generated. One is quotient and another is remainder. So if we want to take, we want to consider only the quotient of the result part, then we use the flow division, double forward slash. And suppose if you want to take only the remainder part of the result, it means when we divide 22 by 5, how much remainder is remain? If you try to this, then you can see the result is only 2. The 22 is completely divisible, 5 4s are 20 and 22 is remaining. The next operator is, suppose for example, if you want to calculate a equal to 5 and b equal to 3, and if you want to calculate, if you want to try to find the a to the power b exponent, then a double asterisk b. A double asterisk b means now the Python function calculate the power of a to the power b. Just check it. Result. You can see 125. If we calculate 5 to the power 3, then you can see the result. 5 to the power 3 is 5 to 5. 5 5 ja 25 and 25 ja 5, 125. The result is zero. So this is the arithmetic operator basically. All these operator plus, minus, multiplication, division, modulus, exponential and floor division. The next one is comparison operator. All of you know very well, when we perform some programming and when we perform some programs, then we need to compare, we need to check whether the left hand side and right hand side are equal, whether the left hand and right side are left hand side is greater than to right hand side, whether the left hand side is less than to right hand side, then this type of operator is known as comparison operator. Or we can say, in other words, we can say these operators are also known as condition making operators. It means if we want to, we are trying to make a condition, then these any one of these operator is used. For example, suppose if you want to check whether a the basic operators are whether a is 10 and b is also 10, and if you try to print a is equal to b, it means the value of a and the value of b. Sir, where this type of operator is used? Suppose for example, if you are trying to match any one of list of student, and if you find out the list of student which complete 22 years, or the salary of employee is 10,000, then we need to check the equality of both the operand. Here, as I mentioned, A and B is the operand, left hand operand and right hand operand. And equal to is a sign, equal to is a symbol which perform the comparison, which perform the check the equality in between A and B. Then the what will be the result? You can see true, because of the value of A is 10 and the value of B is 20. 10. Suppose if I change the value of B is 20 and now I check, you can see the result is false because of both the operands A and B, the left hand side of the operator and right hand side of the operator is not equal. So we can say these are the equality operators. That's why it is known as equal. Sometimes you just check not equal. Suppose 10 and 20 is not equal. You can see, suppose A is 10 and B is also 10. Suppose print A is equal to B. Just check what is the result. The result is true. But if I say A is not equal to B, the value of A is not equal to B, then the value is true because of the A is equal to B, false. In some practical situations, we also need to check the negation of equal to. It means not equal to operator. The third one is greater than. The third one is greater than. A equal to, suppose A equal to 10 and B equal to 20, and check print someone check A is greater than, A is greater than B. The value of A is greater than B? No. Greater than sign. False. But if we check less than, then we can see A is less than B. Yes, true. We can say if we want to check less than or equal to, suppose for example, if I check the value of A is 10 and B is 10 and less than, A is less than or less than to B? No, not less than, it means equal. So if you want to check both the equation, less than or equal to. So true because of not less than but equal to is condition. If any one of them is true, less than or equal to, then it is true. Same like greater than. If greater than and equal to, then it is also true because of not the value of a is greater than to the b, but the value of a is equal to b. Understand? Next, logical operators. In some situation, suppose we need to connect, we need to join, we need to concatenate two or more conditions. Suppose, for example, if you want to check in a single statement A is equal to 10 and B is equal to 20, and I want to check A is greater than B and B is less than A, or A is less than B. So you can see not both the condition are true, only any one of them true and other is false. Because of if A is greater than B is true, then definitely A is less than B is false. But if we want to use both the condition at the same time, then what we use? We use logical operator. Any logical operator is used to join. You use to connect. There are three type of logical operator: and, or, and not. And means return true if both statements are true. If left and right both are true, then true. If or operator, or means any one of them is true. If any one of them is true, then the overall output is true. Not whatever the output of the condition, the output is just reverse. For example, now if A is greater than B and B is greater than A, any one are true, but not both the true. For example, if suppose you open the gate in lift, if the inner door is open but outer door is not open, you cannot move out from the lift. If both the doors are open, so there is use of and. And same in same situation, if we use here the or operator, or means if any one of them is true, not both the true, but any one of, definitely any one of them is true. Like for example, if whenever we use uh, either small letter or capital letter, if we use capital or small both are a, suppose if we want to press a, and if any machine except whether you enter a capital A or whether you enter small a, the machine will be working, should be working. So you use or operator, either the character is equal to small letter or equal to capital letter both. But if you want to uh, prepare a machine which only accept both the operand are true, both the condition generate true, then it is always true. Not suppose any one of them condition is generate true. For example, suppose a is equal to 10 and we print here print A is less than 5, the result is false. But if we put here a special type not, if we write here not, now the output of the condition is false, but not is equal to reverse false, generate to true. You can see the output is true. Why? The output for this condition is true, sorry false, but use of not operator, because using of not operator it generates true. Like this, if the value of a is greater than 5, in that case the value of a is greater than 5, this condition generates true, but using by using not it is generated. So negation, it means you can see and means both the condition are true, or means any one of them true, and not means if whatever the output of the condition it just reverse the output, it just inverse of the output. If the condition generate true it gives the false, if condition generate false it gives the true. Understand? The next assignment operator, all of you know very well, when we write a equal to 10, it means we assigning the value of 10 as to a. So here some assignment, all these operator. Anyone can understand what is the plus equal to? Plus equal to means it is a short form of the addition and equal to operator. It is known as addition equal to operator. Means if the operand of equal to, both the operand left and right are same and other operator is different, then we use the composite assignment operator. This one is known as, all these are known as composite assignment. This one is known as assignment operator, single assignment, and these are known as composite assignment. Suppose for example, if you perform x equal to 5 and you are trying to perform x equal to x plus 5, you can see the output print x. What will be the output? 15. X 5 and then 5 plus 5 10. But in place of this we can use plus equal to x and the output remains same. So this is known as composite assignment. You can use with any arithmetic operator. The assignment operator is combined with any arithmetic operator. These are arithmetic: plus, minus, multiplication, division, modulus, floor division, and exponential. All these operators are combined with assignment operator and create a composite assignment operator. Getting my point?
Good morning, all of you. My name is Professor Mukesh Birla. I am Assistant Professor in Parul University, CSE Department, and I am going to explain you today the fundamentals of artificial intelligence and machine learning. Today we will discuss the data pre-processing. Our agenda is today discussion is the steps involved in data pre-processing. And we can say there are many steps involved in data pre-processing. Here we discuss major steps which are involved and which are taken during the data pre-processing in machine learning. The question arises here, why we need data pre-processing and what is data pre-processing? The major question arises here is that. So I will explain you with example. Suppose for example, imagine in your class you are going to solve and complete your assignment, but your professor does not provide the data. Then it is very difficult for you to complete the assignment. Same here. Similarly, whenever we prepared, we create a machine learning model for any problem, then we have to provide the data to the model. And definitely, data pre-processing means before providing the data, we ensure the data is correct, because of we know very well if we provide incorrect data, then whether your algorithm is correct, whether your model is correct, but the result is incorrect because of you provide the incorrect data. So we take care about the data correctness before providing the data to the model. And this is technically known as data pre-processing. Data pre-processing is the process of preparing the data and making it suitable for a machine learning model. Suppose, for example, you are going to prepare a model for any type of problem. Then, first of all, you need to provide the data. And before providing the data, we are guaranteed the data is correct. If the data is not correct, then we make data correct. And this process is known as data pre-processing. It is the first and crucial step while we create a machine learning model. Whenever we create a machine learning model, the first step is data pre-processing. Data pre-processing is an important step because of, as we discussed, the data is important for the model. And if data is incorrect, then the model definitely generate the incorrect result. While performing the data pre-processing, it is important to ensure the data accuracy. If we are ignore the data accuracy, then our model may generate the incorrect result. Now, we discuss the steps involved in data pre-processing in machine learning. There are basically there are so many steps in the pre-processing, but here we mentioned some important 8 steps for data pre-processing. Number one is acquire the data set. All of you know very well, whenever we talk about the machine learning model, the data is important part of the model. And the collection of data is known as data set. So the first step, we are acquire the data set. Acquiring the data set is the first step in data processing in machine learning. To build and develop machine learning model, you must first acquire the relevant data set. Suppose you are going to prepare a model for medical model, then you have to acquire the relevant data set. Suppose you are going to prepare a model for business application, then you have to acquire the data for business application. This dataset will be comprised of data gathered from multiple and disparate sources, which are combined in a proper format. We also know that if the data is not in a proper format, suppose we can collect the data from multiple sources and multiple places, but the data must be in a proper format. The dataset format differ according to use case. Like, for example, suppose you are going to prepare a model for medical, then you have to use the dataset related to medical healthcare. And if you are going to prepare the dataset for the business application, then your data set contain relevant business data. The second step, once you acquire the data set, then you have to import some libraries for perform operations on the data. And we know very well the Python language is most extensively used and also the most preferred library by data scientists around the world. Python is most important and most preferable language. So we will how to import Python libraries for data pre-processing in machine learning. In our further discussion, we will also explain how import the Python libraries and which libraries are important and play a role in data pre-processing for machine learning. The predefined Python libraries can perform specific data pre-processing job. There are so many libraries in Python which are perform the specific data pre-processing. There are basically three main libraries which are mainly involved and mainly import in a your machine learning model. That one is NumPy. NumPy is the fundamental package and fundamental library for scientific calculation in Python. If you want to perform scientific calculations, then you should, or we can say you have to import the NumPy library. How we can import the NumPy library? We will discuss it later. But just here we mention the name of the libraries which are play important role in data pre-processing in machine learning. The second one is Pandas. Pandas is an excellent open source Python library for data manipulation and analyzing. When we perform data analysis, then the Pandas library is very important library. Matplotlib. Matplotlib is a Python 2D plotting library that is used to plot any type of chart in Python. As all of you know very well, when we perform analysis of any data, then we plot. Our output is in the form of any graph, any chart. So if you want to plot the chart graph of the data, then we have to import the matplotlib library in our model. The third step is import the data set. Once we acquire a data set from any source of, but once you acquire, then we need to import the data set in our model. Acquired dataset is a process of selection of dataset, and import of dataset is a process of import your dataset to a particular ML project. The fourth one is identify and handling the missing values. This one is very important point, a very important step for data pre-processing. All of you know very well, when we collect data from real world application and any source, then may be possible the data can contain missing values. Suppose for example we create a form, Google form, and we collect the data from Google form, and someone fill the empty value in the age, then the field is empty, missing value. So we take care about the missing value. We should handling the missing values in dataset. There are basically two techniques to handle the missing value. Number one is deleting a particular row. If any row in dataset contain missing value in any column, then we delete the entire row. But in numerical data, if any numerical data is containing by your dataset, then we can calculate the mean value for the whole column, and we can put the mean value in place of missing value. So by this we can handle the missing value problem. The next one is handling outlier in data pre-processing. Outlier are the data points that significantly deviate from the rest of the data set. Suppose for example, some data contain all the values are like a particular pattern, but few values are totally different, are very high. Suppose for example, if we talk about a student record, then the age of its student around 20, 22, 21, 23, like that, and someone has the value of 98. That type of value is known as outliers. So we need to handle this type of value as well. And in the context of data preprocessing, identifying and handling outliers is very crucial. The next one is splitting the data set. This one is very, very important because of every learning model have two data set. One is training data set and another one is test data set. We will discuss it later in detail. The training data set is used to train the data model, and the test data set is used to whatever we train, the model is performed according to training or not. We can say we conduct test on the trained model, and for the testing we use a separate data set that is known as test dataset. So we need to splitting the whole dataset into two parts. One is training dataset. In general, the dataset size is large as compared to the test dataset. The next one is dealing with imbalanced dataset in machine learning. In many real world scenarios, dataset are imbalanced, meaning that one class has significantly fewer examples than another. An imbalanced dataset can lead to bias model for that perform well on the majority class but struggle with the minority class. Suppose, for example, here we take an example credit card fraud. If we take the dataset for credit card fraudulence, then we can say the maximum transactions, maximum dataset is correct and maximum dataset is not fraud. But few datasets are fraud. So if the size of correct dataset, correct data and incorrect data is different, and there is not a slight difference, but a huge difference between them, then we can say that this dataset is imbalanced. So we also take care about the feature scaling. The last feature scaling step. Feature scaling marks the end of the data processing in machine learning. It means this step is the last step of our data data pre-processing. It is a method to standardize an independent variable of a data set within a specific range. Suppose, for example, we want to set some features for scaling. It means we can compare a simple variable, a single variable for common grounds. It means there are single variable which compare in two common grounds. It means the data set is scaling or the feature, the column selected is scalable or not.